Okay, so for today's presentation, I will be representing my group on how to demonstrate the necessary skills as well as tricks, including the methods on how to use Microsoft Excel for descriptive statistics. Now, this video will contain all the shortcuts as well as step-by-step on how to present data in a beautiful and analytical way. So, beforehand, we have collected around 40 respondents, asking them about their height. So, the height of each respondent will contribute to our continuous data. So, as you all know, this assignment falls under two categories, which is discrete data and continuous data. So, for discrete data, I will explain later on in this video, but for continuous data, I will show you right about now. So, to begin with, we will need to determine our n, which is the total number of respondents, the maximum value, which is the height of the tallest person out of these 40 respondents, the minimum value, which is the height of the shortest person out of these 40 respondents, our range, which is the maximum value minus the minimum value, our class interval, as well as our class width. Now, without further ado, let's begin. So, as we all know, we have around 40 respondents, so n as the total number of respondents will be 40. Now, for maximum value, by using Microsoft Excel, we have a simple shortcut, which is to simply just type in equals. Now, we need to click and drag all the values present in the blue table here, which is the height of every respondent. Sorry. So before doing that, we will need to type in maximum, and a pop-up will appear here with several other information, but we will just need to double click on maximum, and then we would like to click and drag all the values from the blue table, which is the value of all the height of all respondent, and simply press enter, and it will automatically give us the maximum value for our continuous data. Now, for the minimum value, much similar to our maximum value, but instead of maximum, we will type in minimum, double click on minimum, click and drag on all the values on the blue table, and press enter, and it will give us our minimum value automatically. So for range, it will be our maximum value minus our minimum value. So in Microsoft Excel, instead of just simply using our calculator and calculating it manually, there's a much cooler way, which is to also press equals to, click in our maximum minus our minimum, press enter, and it will calculate the value for us. Simple yet effective. So for a class interval k, we will need to use the equation of 1 plus 3.3 log n. Now, simply key in this equation in this box here. 1 plus 3.3 times log. Now, a pop-up will appear, as you can see. So double click on log and press in 40. Now, we will need to close this bracket before pressing enter, and it will generate the value of around 6.286798. So for class interval k, we will need to round this off to our nearest integer, and that will be 6. So for class width, we will need to use the equation of range divided by k. So much similar to how we calculate the class interval. K in equals to, click in range, then divide this value with our k. Press enter, and it will generate the value for us. Now, as you can see, it gives us the value of 4.916667, and we will need to round this off also to our nearest integer. So 4.9 will, when rounded off, will be 5. So let's just put 5 here. Alright, so after having all these values, now we could move on to create a table presenting other complex data required to present a set of continuous data. Now, in this table we are going to make, we would like to have our class interval, our lower limit, our upper limit, our lower boundary, our upper boundary, midpoint, the frequency, the cumulative frequency, as well as other necessary values needed to calculate the mode, the variance, as well as the standard deviation. So when observing and analyzing, when also after meticulously planning this all these values needed, we have found out it will require us to make around a 7 times 10 table. So simply drag 7, 1, 2, 3, 4, 5, 6, 7, and to the right 10 times 1, 3, 4, 5, 6, 7, 8, 9, 10. Now it will produce a shaded region over here. Right click on that shaded region, click in what we a widget under the name bottom border, and simply click in all borders. Now it will generate a 7 times 10 table for us. So for the first column, we would like to name this column as our class interval. Now for the class interval, as calculated previously, we should have around 6 values. But to aid us in presenting this data better, we decided to only use 5. And for the class width, we decided to use 6. Now, as the minimum value is 156, we will begin putting in our class interval with 156. Now, at 156 with 6, we will get the value of 162. Now, we would like to do this until the maximum value is reached. 169, 170 to 176, 177 to 183, 184 up to 190. Okay, so even though there is a spare box down here, but we will just leave it as anything can be edited later on. Now moving on, we will need to include our lower limit. So our lower limit is simply the lower limit for our class interval. So it will probably be the value of everything on the left side of the class interval, which is 156, 163, 170, 177, and 184. Now moving on, it will be our upper limit. Now for our upper limit, it will be probably be everything on the right side of our class interval. So that would be 162, 169, 176, 183, as well as 190. So after we have done our class interval lower limit, upper limit, we will need to do our lower boundary. Now the values for our lower boundary will simply be our lower limit minus 0.5. Now to do this, all we need to do is press in equals to, click in our lower limit, and minus this value with 0.5. And it will give us a value of 155.5. Now continue doing this for the rest of the column. Equals to lower limit minus 0.5 equals to lower limit minus 0.5 equals to lower limit minus 0.5 equals to lower limit minus 0.5. Now, after completing the lower boundary, it will be relevant for us to also find the upper boundary. Now, the upper boundary is much similar to our lower boundary, but instead of using our lower limit, we would like to use our upper limit, and instead of minus 0.5, we will add it with 0.5. Now, do the similar steps stated for lower limit, which is upper limit, but this time added with 0.5. Now continue this for the rest of the column as well. at 0.5. And voila, we already have our upper limit. And after completing our upper boundary, we will like to have our midpoint. Now the midpoint is basically the lower limit added with the upper limit and dividing that value with 2. So any calculation using Microsoft Excel as a platform will need to begin with equal. So I hope I don't have to repeat that piece of information as we go on. So equals to, now I would like to bracket this up, lower limit plus the upper limit, close this bracket and divide all that value with 2. See, it will give us the midpoint for our class interval. So do similar steps for each column. Completing this will take a bit of your time, but I hope you can bear with me. Now we have the midpoint for every class interval here. So after the midpoint, now this will be a bit tricky. We will move on to our frequency. Now, to find the frequency for each value here, we will need to simply just press in frequency. And here we have already the pop-up emerging below this box. Now double click on that. Now in this bracket, we would like to click and drag all the data in the blue table. Now press in comma and now click in all the data from our upper limit column. Close the bracket and press enter. As you can see, we will have the value for each class interval automatically stated here in this column, which is 11, 12, 13, 2, 2, and 0 for as there is no class interval already there. So after finding our frequency, we would like to add in our cumulative frequency or our accumulative frequency. Now drag this n column a bit to the right to adjust the table, and here we go. So as we all know that the accumulative frequency is just the frequency but added with the value previously. So as there are no values previously from our first class interval, so that we will just leave it as 11. Now 12 added with the previous value, which is 11. Now 12 plus 11, that will give us the value of 23. Now adding 13 with 12 and 11, that will give us the value of 36. Adding 2 to the previous values will give us the value of 38. And adding another 2 to that value would be 40. Now as you can see here, the accumulative frequency will bring us to the total or the sum of all the frequency, which is 40. And as you know, 40 is the total number of respondents. So this is how we know that our accumulative frequency is accurate. Now moving on, we would like to find our fx. Now you might be wondering, what is the fx? So the fx is actually the frequency minus the midpoint of the class interval. This value is very important, as it will help us in finding the variance as well as the standard deviation later on. Okay, now so moving on, we would like to find the value for our fx. Now, some of you might be wondering, what is the fx? So the fx is actually the product of frequency and our midpoint. So to add these values of fx in the column, much like how we have done previously, all we need to do is to first begin with the equal to sign, tap in, click in frequency, now times this value with midpoint. Now it will give us the value of 1749. So continue doing this for the rest of the column. Equals to frequency times midpoint equals to frequency times midpoint equals to frequency times midpoint equals to Now, after finding the values of fx, we would like to find the value of fx squared. Now, the fx squared will just be the value we will use later on when finding the variance and the standard deviation. So, to make things easier for us, let's just put it in our table. So, as you all know, so the fx squared is just the value of fx raised to the power of 2. So, let's just do that very fast. And that would be our fx squared. So that is all for the table I have presented to all of you the necessary information we need that should be put in the table. We have our class interval here, our lower limit, continued, followed by our upper limit, lower boundary, upper boundary, midpoint frequency, and as our accumulative frequency. We have also added two additional values, which is our fx and our fx squared, to aid us in finding the variance and standard deviation later on. So after completing this table, what I would like to do now is find the median class. So what is the median class? So the median class is probably the class interval holding the median value for the entire set of continuous data here. So after doing this, how we would like to do this is just by dividing our n with 2. So 40 divided by 2, that will give us the value of 20. Now let us look at our frequency here. So 20 will probably not be in the first class interval and also not in our second class interval, but it would probably be in our sorry, I think our median class is right here in our second class interval. So to help us, let's just highlight this thing out. Okay, so now we already have the class median, the median class. So let's just put that value here, 0.2. Now L is our lower boundary, which is 162.5. Now what I would like to do next is find the median class. So the median class is actually just the class interval holding the median value. So in this graph, after properly analyzing each and every value presented in the table, I have found that the median class for this set of data is 170 to 176. So to help us give a better visualization on this median class, let's just highlight this thing out. And here we go. So after doing this, I would like to fill in this table. Now this table is the table that will help us into calculating our mode, variance, standard deviation, and our median. So L is our lower boundary of the median class. Now what is the lower boundary of median class? Well, let's just look that up in our table. So it is 169.5. Now after that is our D1. So D1 is the value of the frequency of the median class minus the frequency before it. So 13 minus 12. Now 13 minus 12 will give us the value of 1. Now D2 is the value of the frequency of the median class minus the frequency of the next class interval. So 13 minus 2. So 13 minus 2 is 11. Now the model class right now, which is our C, is 7. So going on is our median class, and as highlighted, our median class is 170 to 176. Our big F right here is actually our cumulative frequency. So up until now, our cumulative frequency for our median class is 36. Every value here is somewhat related to our median class. And the small f here is simply our frequency, which is 13. And n, as we all know, is just the total number of respondents, so that is 40. Now, after finding all these values here, we can conclude, or we can determine each and every measures of dispersion as well as measures of central tendency needed to present a proper set of continuous data, such as our mode, variance, standard deviation, and median. Well, as you can see in the formula stated here, every component is already been identified from the table we have constructed previously. So we can simply just key in these values into the equation and find it manually or by using Excel. And if we want to use Excel, as stated before, we will just need to begin with an equal to sign and simply just click and tap in the values in the small box here. So that is all on how to present data by using Microsoft Excel specifically for continuous data. Now, I would like to continue with discrete data, which will be continued by my friend. Thank you very much.
Assalamualaikum and hi everyone. So today I'm going to present about the discrete data. Before that, we need to know what is discrete data. Discrete data is a data under the quantitative data. And the definition for the discrete data is a numerical response which arises from the counting process. So in order for us to obtain the discrete data, we have conducted a simple survey on the Microsoft form towards the UTP students on how many shoes they do have. And luckily, we have obtained approximately 40 respondents. And after we have obtained after we have obtained data from the respondents, we are going to determine and find another information from the data, such as minimum value, maximum value, range, class interval, class width, midpoint, frequency, cumulative frequency, lower limit, upper limit, lower boundary, and the upper boundary. And to obtain those information from the data, the step and the calculation is just like the calculation for the continuous data. So I'm going to skip that part and go directly to another calculations, such as the calculation for determine mean, mode, median, variance, and standard deviation. Now we are going to determine the mean of the data. The mean is an average of certain amount of numbers. So now we need to sum up all the data that we have um, obtained and divided it by the total number of respondents that we have obtained, which is 40. And we're gonna get 3.9. And that is our mean for this data. Secondly, for the mode is the most frequent number in a group of data. And we have the formula to determine the mode, which is L plus D1 over D1 plus D2 multiplied by C. And we just substitute those value and we're gonna get 3.38888889, and that is the mode of the data. And then we're going to find the median. So median is a middle value of data in a list ordered. And to find the median, we're gonna use the formula here, which is L plus n over 2 minus f divided by f and multiplied by c. And we're gonna get 3.61111111 for the median. And next we're gonna find the variance, and variance is a measure of variability, and variance will tell you the degree of spread of your data set. The more spread the data, the larger the variance is in relation to the mean. And there is a formula for us to find the variance, and we gonna substitute those value into the formula, and we're gonna get 4.3487179595 for the variance. And the last one is the standard deviation. And the standard deviation is calculated as the square root of variance by determining each data point's deviation relative to the mean. So we just square root the variance and we're gonna get the standard deviation. So the standard deviation is 2.0853579. And I think that's all for the